If f is differentiable, then it's continuous. But if f is continuous, it's not differentiable. Continuous can be derived from differentiability. I have this, right? So what is this? Fx minus fa. I can always take this limit, right? If they exist, okay? Then what? I create stuff. I can create stuff because they are not zero. They are not zero before I take limit. They are zero after I take limit. So that's different. And after I do this, I can now split them inside because this is before the limit. So I can do that. And then now what? This is just zero. So therefore, I have this. So what is this? Limit of this is zero. Is again, I do this. And then limit of this is what? It's not fa. It's a constant function that the value is always fa. So that's why I have this. What does this mean? This is what we talked about last week. This means f is continuous because this guy exists and is equal to the value exactly at that point. So this is what? Continuity. So that means if you can take differentiation, what? This part, then you have continuity. But continuity do not imply differentiable. This is the example. Absolute value is not differentiable. This is absolute value. Differentiation is slope, right? Okay, this part, the slope is positive 1. This part, the slope is negative 1. At this point, so suddenly I have a jump from negative 1 to positive 1. Function do not allow this, so this is not function, so therefore it's not continuous. Therefore, blah blah blah. Yeah, this is true, but to make it formal, you need to prove the limit do not exist. There are 4 ways. You use the H definition, you use the Q definition, or you use left-right limit, or you use epsilon delta. So this is one way. I'm going to use a left-right. So H to 0 minus means from the left. This means from the right. So I have this. What is this? Fh is absolute value, right? For anything that is negative, it is negative sign with the H, right? So therefore this part is negative. This guy 0. I don't care. It's 0. Absolute value 0 is 0. So I don't write it. This part stay there. I have here. So negative 1. This is a constant function of H. So that's why it's negative 1. What about positive part? Same. This part is 0 because this is absolute 0, which is 0. So I don't need to write it. Fh. This is from the positive part. So this guy is what? Absolute value of something positive is just the stuff inside. So I have this. So H divided by H 1. So I'll have what? 1 is negative 1. 1 is positive 1. They do not agree with each other. Therefore, not differentiable. But this is differentiable. I suddenly add a X here. Suddenly this is differentiable. So now let's see. Same thing. So I'm talking about this thing, which is the blue thing. The blue looks like this. Is it differentiable here? We just show that absolute value is not differentiable here. But what about the blue thing? It turns out it's differentiable. So do the same trick again from the left. So I have fx. So now I need to know what is fx for the negative part. This is what I'm doing here. For negative, I have this. Okay. Then I just plug it in. And then what I will get? I will get h, right? But I have negative sign. H goes to 0. So 0. What about positive part? Positive part is fx minus f0. So positive, I need to get the expression of fx. For positive, this is just x. Xx, so x squared, right? So I have this. Again, I don't care about 0. H cancel out. So I have just 1h. Limit go to 0. 0. So now left, right equal. So this particular guy, limit exists for the differentiation. So therefore, this guy is differentiable. In the exam, I will probably ask you, is this differentiable? Is this differentiable? Is this differentiable? Simple function. But you cannot answer, oh, is this differentiable in 1 second or 5 seconds? Now you see, very easy for me to come up with some question that suddenly will stuck you forever. Now you see, this function is continuous but not differentiable. This function is continuous but differentiable. And then suddenly I put a square, I put a square root, and then I divide them by themselves. So this is university level thing that we always ask to the root. Don't tell me, oh, I know how to find the derivative of x squared, and you think you know calculus. No. And then with all this thing, we write a fancy symbol. We write dy dx. This means I do this. This is the h definition. I can do the q definition. I can do the epsilon delta definition. They means all the same thing. And then this bullet point 2.3.1.16 very important. If you have a differentiable function, and if it's differentiable everywhere, you have something called continuously differentiable. All I just said is differentiable at one point. I didn't say differentiable at everywhere. So if you are differentiable everywhere, of course you are differentiable at a particular point. And then I just showed you previously, differentiability gives you continuity. And continuity is what? It's a limit, right? Limit of the f at the a is exactly fa. So that means limit exists. And if limit exists, that means the limit from the left have to agree the limit on the right. Now, this one small sentence looks very short. Behind it is 20 pages of stuff, which I can ask you in exam.